Welcome back. Now we want to learn how we can use the method of completing the square to solve our quadratic equations. So we're going to be looking at some examples. So let's look at this example. Right, it's saying solve the following equations by completing the square. So on A we have x squared plus 8x minus 1 is equal to 0. On B we have x squared minus 3x minus 7 is equal to 0. If you can recall from the previous lesson, we were learning how to complete the square given some quadratic expressions. But now we want to use the same method now to solve our quadratic equations. So let's look at part A first. On part A we have x squared plus 8x minus 1 is equal to 0. Now what we do first is we take the constant term to the other side, to the right hand side. So negative 1 becomes positive 1 on the right hand side. That means that we'll be left with x squared plus 8x is equal to positive 1 on the right hand side. Next, I'm going to make the left hand side a perfect square. So that's completing this square. Now, to make the left hand side a perfect square, that means I have to add a constant, which according to what we said in the previous lesson is half of the coefficient of x squared. Now the coefficient of x on the left hand side is 8. Half of that is 4, and so it means the constant that we have to add is 4 squared, which is half of the coefficient of x squared. So that means we'll be having x squared plus 8x plus 4 squared, and this will be equal to 1. And since we have added 4 squared to the left hand side, then remember, since it's an equation, whatever we do on the left hand side we also do on the right hand side. So we also add 4 squared to the right hand side. So our equation is still balanced. On the left hand side now we have a perfect square, which we can write in the form x plus a squared, and in such a way it will come out as x plus 4 squared, and it will be equal to 1 plus 4 squared. 4 squared is 16, and 1 plus 16 is 17, so this will be equal to 17. Alright, now we have our equation here, and we can now easily solve for x first by removing the squared here, and we do that by introducing a square root for both sides. So we square root both sides, and on the left hand side then we'll be left with only x plus 4, and on the right hand side we'll be having now plus or minus the square root of 17. Next we shift 4 to the other side, to the left hand side, becomes negative 4. So we'll be having x is equal to minus 4 plus or minus the square root of 17, and this becomes our solution for the value of x. Right, this is our exact solutions. These are minus 4 plus or minus the square root of 17. But if you have been given a degree of accuracy and maybe you want to express it to say 3 decimal places or a given number of significant figures, then it will be necessary for you to find the square root of 17 either using your calculator or tables. So the square root of 17 is 4.123 to 3 decimal places. So that means that our solutions will be minus 4 plus the square root of 17, but we will be using 4.123, so it's minus 4 plus 4.123, or minus 4 minus 4.123. And if we simplify this, then we'll be having our solutions as 0.123 or negative 8.123. So that's simply how we solve quadratic equations by completing the square. Now if you have understood the part A, you may want to try out part B by yourself, just to make sure that you have grasped this method. So I'm gonna give you a few minutes, so you may pause this video and start working on part B. Now let's go together to part B. On part B we have x squared minus 3x minus 7 is equal to 0. Now, just like we did on the first example, on example A, we take the constant to the right hand side and it becomes positive 7. That means that we'll be left with x squared minus 3x is equal to 7. Then I make the left hand side a perfect square, that is completing the square, and I have to add half of the coefficient of x squared. The coefficient of x in this case is -3. Half of that we divide by 2 and we square. So that's what we have to add to the left hand side to make it a perfect square. So that means we'll be having x squared minus 3x plus minus 3 over 2 squared, and this will be equal to 7. We add the same so that our equation remains balanced. So writing our left hand side in the form x plus a squared, then that means that we'll be having x minus 3 over 2 squared, and this will be equal to simplifying what we have on the left hand side. You know, -3 over 2 squared is actually 9 over 4. So this will be 7 plus 9 over 4, and 7 plus 9 over 4, that gives us 37 over 4. So that's what we have on the right hand side. And now the next task for us is to remove the squared so that we can get down to finding the value of x. So we introduce the square root for both sides, and if we square root both sides, then the left hand side will be now x minus 3 over 2. It removes the squared. And the right hand side now, the square root of 37 over 4. You need to know the square root of 37 over 4 is the same as the square root of 37 divided by the square root of 4, and we know that the square root of 4 is 2, so it can come out as square root of 37 over 2. So that's exactly what we have on the right hand side. We'll be having plus or minus the square root of 37 divided by 2. And next we can shift -3 over 2 to the right hand side, becomes positive. So we'll be having x is equal to 3 over 2 plus or minus the square root of 37 over 2. Right, so this is the exact solution in third form, but now it may be necessary for us to find the solution to maybe, let's go with 3 decimal places. So we now have to look for the square root of 37 using the calculator or tables, and the square root of 37 is 6.083 to 3 decimal places. So that means that our solutions will be 3 plus 6.083 divided by 2, or 3 minus 6.083 divided by 2. Now we can simplify this. 3 plus 6.083 is actually 9.083, and that's divided by 2. And 3 minus 6.083 gives us minus 3.083 and divided by 2. And simplifying this, then our final solutions to 3 decimal places will come out as 4.542 or negative 1.542, or answers given to 3 decimal places. Right, so the degree of accuracy depends on the question, what is required in your paper or on the question, whether the answer is required to 3 decimal places or 2 significant figures. You just have to know the degree of accuracy required by your question. But this is simply how we use our method of completing the square to solve quadratic equations. I'm going to be giving you more examples, more problems to work, so that you may learn more on how to do this.